Welcome to our very last lesson of the school year. I can't believe we are here already. Today we are going to be looking at inverse trigonometric ratios. For your central question, I want you to answer, when do we use inverse trigonometry? So before we get to today's lesson, I want to take a look at a few things that we're already familiar with, just to kind of explore through these. Move this out of the way. Okay, so we are solving each equation for x. So here we have x plus 2 is equal to 8. What do we do here to get x by itself? We are going to subtract 2 on both sides. Now, why do we use subtraction here? We use subtraction because subtraction is the inverse of addition, and we use inverses to undo the operations that are currently being used. So if we're adding 2, we're going to use subtraction because it's the inverse to undo that addition piece. Well, what happens when we use the inverse is that this becomes 0. So we get x plus 0 is equal to, well, 8 minus 2, which is 6. So that leaves x by itself, or that allows us to isolate the x. Same thing here. If we have x minus 2, we will here use addition because, again, it's the inverse of subtraction. So that leaves us with x plus 0, or x minus 0, is equal to 10. For this one here, 2 times x is equal to 8. We're multiplying. The inverse of multiplication is division. So we will use division to undo that multiplication because it is the inverse. 2 divided by 2 is equal to 1. So that leaves us with 1x is equal to 4. Lastly, we have x divided by 2 is equal to 8. We're dividing by 2. To undo that, we must multiply by 2 because multiplication is the inverse of division. So we will multiply both sides of the equation by 2 to undo that 2. 2 divided by 2 leaves us with 1x is equal to 16. So here we use inverse operations to undo the operations that are happening within the equation in order to isolate our variable, in this case, the x. So we're going to look at some inverse trigonometric functions today. So the inverse of sine is just that, sine inverse. So if you look at your calculator, above the sine button, it says sine to the negative 1. It looks like this. Now, that represents the inverse of sine. So we're going to read this as sine inverse. You'll see the same button over the cosine button, cosine inverse, and the same button over the tangent button, tangent inverse. Now we use the inverse to undo these functions here. So if we needed to undo the sine function, we would use the sine inverse. Same thing with cosine, same thing with tangent. Now, I'm going to show you these words. I want you to be familiar with them. You'll see these used in other math classes. Sine inverse will also be referred to as arc sine. Cosine inverse will also be referred to as arc cosine. And tangent inverse will also be referred to as arctangent. Again, just some words I want you to be exposed to, be familiar with. I will refer to them as sine inverse, cosine inverse, and tangent inverse, but you will eventually at some point probably hear them referred to as arc sine, arc cosine, and arctangent as well. Let's go ahead and take a look at our guided practice problem. All right, so here Again, we want to start with our reference angle. So our reference angle is now theta. So with respect to theta, we are given the side opposite of theta, and we are also given the hypotenuse of the triangle. So if we use this information to set up an equation with our trigonometric ratios, opposite and hypotenuse is the ratio we will use with sine. So we will set up our equation as the sine of theta, that's our angle, sine of theta is equal to the side opposite divided by the hypotenuse. Now theta is what we are looking for. Theta is our variable here. And so in order for us to get theta by itself, we have to get rid of this sine function. So we have to use the inverse of sine to undo this. So what we're going to do here is we're going to use the sine inverse on both sides of the equation in order to get theta by itself, just like we do with addition or subtraction or multiplication or division. So the inverse undoes the sine, leaving us with theta, and that is equal to the sine inverse of 11 divided by 27. So again, I want to show you, for each of you that have different calculators, I want to show you how to type this into your calculator. So we're looking to, and this should be theta here, we're looking for the sine inverse of 11 divided by 27. So starting with this calculator here, the first thing you're going to do is push the second button. You're going to push second and then the sine button. Now, when you do that, you're going to see the sine inverse, sine -1, pop up on your screen. So you're going to push second, sine, and then you'll see parentheses pop up if you type in 11 divided by 27, and then push equals. And you should get 24.042, etc. Now, when we are looking for missing angles of a triangle, we want to round those to the nearest degree, which is the nearest whole number. So the answer here is going to be 24 degrees. So theta is equal to 24 degrees. For this calculator here, what you're going to do first is divide 11 by 27. So 11 divided by 27 equals. Then you will push the second button and then the sine button, and that will give you an answer of 24.04, etc. And this last calculator here, you will first push the shift button in the top left corner, shift and then sine. Again, you will see sine -1 pop up on your calculator screen. Then you will type in 11 divided by 27 and then push your equal sign. And you also should get an answer of 24.04, etc. Let's take a look at another one. Again, starting with our reference angle theta, with respect to theta, we are given the side opposite as well as the side adjacent. Opposite and adjacent is our tangent ratio. So the tangent of theta is equal to the side opposite divided by the side adjacent. Now we need to get theta by itself, so we need to get rid of the tangent. So we use the tangent inverse to undo that. That leaves us with theta is equal to the tangent inverse of 3 divided by 10. Make sure that you are writing this step so that I see what it is you are typing into your calculator. So go ahead and type this into your calculator using whichever order you need to for your specific calculator. And if we round to the nearest degree, we're going to get theta is equal to 17 degrees. Take a look at one more. Here we have our reference angle theta. With respect to theta, we're given the adjacent side as well as the hypotenuse of the triangle. Adjacent and hypotenuse is our cosine ratio. So the cosine of theta is equal to the adjacent side 15 divided by the hypotenuse 22. We need to get rid of the cosine, so we use the cosine inverse. Make sure we always do that to both sides. That leaves us with theta is equal to the cosine inverse of 15 divided by 22. We type that into our calculators. We round to the nearest degree, the nearest whole number, and that's going to give us 47 degrees. And that is using inverse trigonometry. Don't forget to answer your essential question.